Okay, the countdown continues. 4 days. And we just be done. Till we are done calculus. Still have a final exam, yep. No. It's 8.5 by 11, your usual. I never get tired of that one. Thanks for the setup. Appreciate it. We rehearsed that beforehand. Well, you're right before lunch, so I'll give you the 80 minutes and let you go through lunch if you need to. But just think, that exam's done, right? Oh, geez. We'll get there, okay? We'll cross that bridge. If you guys saw the exam, you'd be like, awesome. The prep we're going to do for it. If you really look at what we've been doing, we really haven't stopped doing the stuff that we learned at the beginning of the year. Okay, so we're still doing derivatives. We still are doing limits, right? If you look at 20-1, right, like they have to go all the way back to doing, no, I can't even remember half the units. Yeah, the series and sequences, right? Yeah. So, okay. So today's pretty nice day. Tyson, you with me back there? Good. I just staring at your groin part. It always weirds me out. Okay. So now we're going to find the area between two curves. So this wants, you've got your upper curve, which is x squared plus 3, right? So this is y equals x squared plus 3. And then you've got your lower curve, which is y equals x plus 1. And it wants the area between the two curves between 2 and 4. Okay, so this is 0, 1, 2, 3, 4. So this is what it wants the answer to. Okay, so what we could do is we could find the area of this one, right, the red one, which is x squared plus 3, and just subtract the area under x plus 1, and we should get the blue. Okay, so all we're going to do is take the red area, subtract the black area, and we should be left with the blue. So let's find the area of the blue. Okay, so the red. Let's find the area of everything under x squared plus 3. So we will find all of this, all the way down. Okay, so let's go first with finding our antiderivative. So f of x equals x cubed over 3 plus 3x. Okay, so we're going to find the area from 2 to 4. So we'll do the 4 first. So 1/3 times 4 cubed plus 3 times 4 minus 1/3 2 cubed plus 3 times 2. Okay, and just to speed things up, we get 74 over 3. Okay, so that would be the entire area from x squared plus 3 all the way down to the x-axis. Now, if we can find out the area under x plus 1, then we're going to take those two and subtract, and we'd be just left with the difference. Okay, so 274 over 3. Everyone just loves giving her a rough time. Is that what you kind of picked up a pattern? Okay, so now we're going to find just this little area of y equals x plus 1. So f of x would equal x squared over 2 plus x. So we'll do from 2 to 4. Be 4 squared over 2 plus 4 minus 2 squared over 2 plus 2, and you will get 8. Okay, so now area should equal well, let's call this A1, call this A2. So if we take A1 minus A2, we get 74 over 3 minus 8, which equals 50 over 3. Okay, now there's another method that actually works equally as well, and that is if you take and subtract the two equations right from the beginning, the upper minus lower, and it's like bringing down the equation. Okay, so new f of x is x squared plus 3 minus x plus 1. So you can see the importance of the brackets there because of a minus sign. So that's x squared, and then just a minus x, and then it'll be 3 minus 1, so that's plus 2. So you can see this is a lot more time savings, but I needed to show you the other way, because if I did this, some students would ask, could you just take the two graphs and subtract the areas? And you never know if you've got extra time in your test and you're like, okay, I'm done. Maybe I should try the other way and make sure I got it right. Now, let's find the antiderivative. So 1/3 x cubed minus 1/2 x squared plus 2x. And again, we don't have to put the c's because they'll subtract out anyway. So if we go from the area from 2 to 4, that would be 1/3 times 4 cubed minus 1/2 times 4 squared plus 2 times 4, all subtracting 1/3 times 2 cubed minus 1/2 times 2 squared plus 2 times 2. Put that all in, and guess what you get? 50 over 3. One more example. Okay, so find the area between the two curves y1 and y2. Now they don't give us the limits. So that is where this second example comes in. We need to go and find where they actually intersect. Okay, now let's kind of do a diagram here. We've got 4 minus x squared, which is the same thing as negative x squared plus 4. So that's actually right here, and it's going down here. Okay, and then we've got 2x squared minus 8. So it's down here with a y-intercept of minus 8. And it's doing something like this. And this is going to be the answer. Now, the obvious question is, well, why can't I take the area of the top one, add the area of the bottom one? Because that only does it between here and the x, and here and the x. And I think if these both intersected perfectly at the x, that would work. But they don't. Okay? So in this case, and I purposely tried to draw, like it might, who knows, right? But I purposely tried to show that they don't intersect at the x, right? Because then I could just do this area plus the absolute value of this area, and that'd be good. Okay? So first thing we need to always do, similar to the last one on the quiz, where we have to sometimes find out where the zeros, this is find out where they intersect. And so number one, find out where they intersect. So the best way to do that is go when y1 equals y2. So when does 4 minus x squared equal 2x squared minus 8? Okay, so we can add x squared. That'll give me 3x squared. I'm going to add 8. That gives me 12. Then divide both sides by 3. 4 equals x squared. Take the square root of both sides. Plus or minus 2 equals x. Now, these ones do actually happen at the x. Because if you put in 2 for both of them, you get y's of 0. Okay, so that one does work out. So you could solve this one both ways. Okay, but that's not always. Since we learned this new awesome way to do it. So let's find out our new f of x. Actually, and it's a lot less work doing it this way. And let's face it, we're all into less work. So you always want to go upper minus lower. So a diagram does help because the upper would be the more up one. And the diagram showed me which one that was. So this would be 4 minus x squared minus 2x squared minus 8. Yep. When? Oh, when they're on top of each other, you can. If it was like this, that's a good question, right? If it was like this, and you did upper minus lower, right, then it's not going to work out. Because those two don't even intersect. Okay? Now that's a really good question. Okay? I was actually talk about that a bit later. If they're not on top of each other, then you're not going to do upper minus lower. Yeah, you're going to have to do this plus absolute value of that. And that's why a diagram will show you which approach you're going to take. No, you don't have to do absolute value. It just works out. Because you did this equation, you're not even going down that road of the two areas, right? But if you were doing it the other way, yes, you'd have to do the upper, absolute value of the lower, and add the two areas together. Okay. So when we do this, we get 4 minus x squared minus 2x squared plus 8 equals negative 3x squared plus 12. Okay, that's our f of x. So let's do f of x would be negative x cubed, right? That'd be negative 3x cubed divided by 3, but that goes away, plus 12x. So this one is a huge time saving, as long as they are on top of each other. So let's go from negative 2 to 2. So we're going to do f of 2 minus f of negative 2 equals. So that is negative. Now remember, the 2 is not with the negative sign. Oops, it's cubed. So we do want to put it outside the brackets, or else you're going to get the wrong answer. Plus 12 times 2 minus negative, again, negative 2 cubed plus 12 times negative 2. Okay, this is negative 8 plus 24 minus 8 minus 24. Negative 8 is negative 16. 24 plus 24 is 48. Your answer is big 32. Okay, and then we're not going to do this. We'll do activity 10.2 that you already have. So it's a pretty short assignment. You don't have to do overkill on these, and you have all the solutions. So it should be a pretty non-frustrating day. I'm hoping for you.